Have you ever wondered how computers make decisions? Well, it all boils down to a fundamental concept in programming known as conditional statements. These critical constructs are the driving force behind the decision-making ability of a computer. They control the flow of a program by executing different blocks of code, depending on whether a certain condition is met or not. Think of them as the traffic lights of programming, directing the course of the program based on specific conditions. From simple operations like checking if a number is positive or negative, to complex algorithms that drive artificial intelligence, conditional statements are at the heart of it all. They form the backbone of logic in programming, enabling our applications to interact, respond, and make decisions. So, let's dive into the world of conditional statements and see how they enable your program to make decisions. Imagine a situation where you want something to happen only if a certain condition is true. That's where the if statement comes in. Let's dive right into it. An if statement is like the decision-making ability of your program. It can evaluate a condition and decide the next course of action based on whether the condition is true or false. Talk about empowerment, right? Now you might ask, how does it work? Well, it's quite simple. The if statement checks a condition, and if it's found to be true, it executes a block of code. If the condition is false, it skips the code block and moves on. Let's illustrate with an example. Suppose we have an integer x, and we set its value as 10. We want our program to print a message x is greater than 5, only if x is indeed greater than 5. Here's how we do it. We write if, followed by the condition in parentheses, x is 5. Then we open a code block with a curly brace. Inside this block, we put our instruction to print the message x is greater than 5. Finally, we close the code block with another curly brace. So when the program runs, it checks if x is greater than 5. Since we've set x as 10, the condition is true. Hence, the program prints x is greater than 5. If x were less than or equal to 5, the program would not print anything as the condition would be false. What's great about the if statement is its simplicity and versatility. It's like a gatekeeper, opening the gate if the condition is met and keeping it shut otherwise. It's a fundamental aspect of programming, allowing you to control the flow of your code based on specific conditions. Remember, the if statement is all about making decisions based on conditions. It's about telling your program, hey, if this condition is true, go ahead and do this. If not, then let it go. And that's the if statement for you, a simple but powerful tool in decision-making in programming. Now, what if you want to execute a different block of code if the condition is false? Enter the if-else statement. The if-else statement is like the if statement's more versatile sibling. It gives your program the power to not just make decisions, but also to make choices. Sounds intriguing, doesn't it? Let's dive right in. Imagine a scenario where you've got a number and you want to find out if it's even or odd. You'd start off with an if statement, checking whether the remainder of the number divided by 2 equals 0. If it does, that means the number is even. But what if it's not? That's where the else part comes in. When the condition in the if statement evaluates to false, the else clause is triggered. This allows you to execute a completely different block of code. In our scenario, if the number is not even, then we can confidently say it's odd. So we put that conclusion in the else block. So how does this look in code? Let's take a look at a simple example. Let's say we have an integer y which is equal to 3. We then write an if-else statement to check if y is even or odd. The if condition checks if y modulo 2 equals 0. If true, it prints out y is even. However, if this condition is false, the else clause kicks in and it prints out y is odd. And because our y is 3, which is an odd number, y is odd gets printed. This is the power of the if-else statement. It gives your program the ability to adapt to different situations and respond accordingly. Whether you're sorting numbers, validating user input, or making complex decisions, if-else statements are there to help your program make the right choice. Remember, every else is essentially saying, well, if all else fail, do this. It's your program's safety net, catching any scenarios that the if didn't cover. So, the if-else statement gives your program the ability to choose between two courses of action. But what if you have more than two possible courses of action? That's where the if-else statement comes into play. Imagine you're writing a program to grade a student's paper. The grades range from A down to fail, and each grade corresponds to a certain percentage range. An if-else statement is perfect for this scenario. You start with the if statement to check the highest condition first. Let's say A is for scores of 90 or above. So you write, if grade is greater than or equal to 90, then print A. But what happens if the score is less than 90? Here's where else if comes in. It's a way to check another condition if the previous one was false. So you write, else if grade is greater than or equal to 80, then print B. You can have as many else if statements as you need, each checking a different condition. For C, you'd write, else if grade is greater than or equal to 70, then print C. Finally, if none of the previous conditions are met, the else statement catches everything else. In our example, if the grade is less than 70, the student fails. So you write, else print fail. So to sum it up, the if-else statement begins with an if, followed by one or more else-if statements, and ends with an else. The code block corresponding to the first true condition gets executed. If no condition is true, the final else block gets executed. This gives your program the ability to make complex decisions, testing multiple conditions in a specific order. It's like a cascading waterfall of checks, where the flow of water, or in our case code, follows the first path it finds open. Remember, programming isn't just about making your computer do things, it's about making it think, reason, and make decisions just like a human would. And conditional statements like if-else are the building blocks of that decision-making process. And that's how the if-else statement allows your program to handle multiple conditions. Now let's talk about a situation where you have to test a variable or expression against multiple possible cases. Here, the switch statement proves to be a handy tool. Imagine you're creating a program that needs to display the day of the week based on a numerical input ranging from 1 to 7. You could use a series of if and else-if statements, but that could become quite lengthy and cumbersome. Instead, you can use a switch statement. This allows you to test a variable or an expression against multiple possible cases, executing the corresponding block of code when a match is found. Let's look at an example in Java. We declare an integer variable, day of week, and assign it a value, say 3. Now, we can use a switch statement to determine what day of the week it corresponds to. We start with the keyword switch, followed by the variable to be tested in parentheses. This is followed by a set of curly braces enclosing various case statements. Each case represents a possible value for the variable. If the variable's value matches that of a case, the code following the colon is executed. In our example, the case value 1 would correspond to Monday, 2 to Tuesday, and so on. For our variable value of 3, the output would be Wednesday. Don't forget the break statement at the end of each case. This is crucial because it stops the switch statement from continuing to check other case values once a match has been found. If you omit the break, your program might produce unexpected results. What if our day of week variable holds a value that doesn't match any of the case values? Here, we can use the default case. This acts as a catch-all for any values not specifically addressed in the case statements. In our example, if day of week is anything other than 1 to 7, the default case would output invalid day. And that's the switch statement for you, a powerful tool for handling multiple possible cases. So, we've seen how conditional statements play a vital role in decision-making in programming. we've delved into the world of if-else, if-else, and switch statements, each offering us a unique way to control the flow of our programs based on specific conditions. We've learned that if statements execute a block of code if a condition is true. If-else statements take it a step further by giving us the ability to execute alternate code when the condition is false. If-else statements, on the other hand, allow us to test multiple conditions and execute different blocks of code accordingly. Finally, switch statements test a variable or expression against multiple possible cases. We've also touched on key concepts like Boolean expressions, comparison operators, and logical operators, which are paramount in creating conditions in these statements. Remember, conditional statements are the backbone of decision-making in programming, so keep practicing and you'll master them in no time.